All right, so here's another method we can use when it comes to approximating a definite integral. It's the Simpson's rule, or you can call it the parabolic approximation. So we're creating parabolas to approximate the area of a curve. So if you want to integrate from a to b of some function f of x dx, this can be approximated by the Simpson's rule, which is delta x over 3 times f of x evaluated at the first endpoint f of x naught, plus then you have to do 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3, and you got the idea. So you multiply each of these values in between by 4 times 2, 4, 2, 4, 2, 4, 2, and so on, all the way up to the last two. So you'll have 4 times f of x and minus 1. So before the last x value plus f of xn. So that's the formula we use when it comes to approximating the Simpson's rule. So delta x is the same delta x from before, from trapezoid rule or any other approximation you have learned. Delta x is given by b minus a divided by n. So n is the number of subdivision we make or number of partition you make. One thing you have to keep in mind that n is even for this method to work. So that's one thing to keep in mind. Right, so let's go ahead and figure out how to do this by using an example so that you're familiar with this approximation as well. So let's use the Simpson's rule to approximate the value of this integral from 0 to 4 of this function 1 over x plus 1 using n equals 4. So that's the number of subdivision we're going to make on the interval 0 to 4. So we know our f of x is going to be 1 over x plus 1. We're looking at the interval from 0 to 4 and is number of subdivision, so that would be 4. So usually I like to do this. I draw the interval, so we're looking from 0 to 4, subdividing into 4 subintervals, so 1, 2, 3, 4. Let's find delta x, so that would be b minus a over n. So this is your a, this is your b, n is given. So this would be 4 minus 0 over 4. So that would be 1. So 0 plus delta x, this is 1. 0 plus 2 delta x, that would be 2, 3, and so on. So those are the values for your x naught, x1, x2, x3, and x4. Now, to approximate the area, we're going to use the Simpson's rule. So this integral from 0 to 4 of the function 1 over 1 x plus 1 dx is approximately delta x over 3. So that would be 1 over 3 times f of x naught. X naught is 0 plus 4 times f of x1. X1 is 1 plus 2 times f of x2, that would be 2. So f evaluated at 2 plus 4. So you're alternating 4, 2, 4, 2, and so on until the last one, no values in front other than 1. So it'll be 4 times f of x3, that would be f of 3. And the last one is this one, x4. So that would be plus f evaluated f4. All right, now let's go ahead and find these function values by plugging them into the function f of x right here. So we will have 1/3 times f of 0. That'll be 1 over 0 plus 1. That's 1 plus 4 times f of 1. So that would be 1 over 2 plus 4 times f of 2. That would be 1 over 2 plus 1. That's 1 over 3 plus, so like I made a mistake. This is 2. So that was this one. And then the next one will be 4 times f of 3. So that's 4 times 1 over 3 plus 1. That's 4. Plus the last one, f of 4. That'll be 1 over 4 plus 1. That's 1 over 5. So that's how you set this up. And now let's simplify it. So this is 1 over 3 times 1 plus 4 times 1/2, that's 2, plus 2/3, plus 1 plus 1/5. If you add these up, you will get about 73 over 45, which is approximately 1.62. So that's the approximated area by using Simpson's rule. Now let's go ahead and find the exact area. So to find the exact area, we're going to integrate these functions. Tim, we know how to integrate this. So here's the actual area of the function from 0 to 4 of 1 over x plus 1 dx. So we know how to integrate this. This is going to be ln an absolute value of x plus 1 going from 0 to 4. Now you can drop the absolute value since we're only looking from 0 to 4. It's going to be positive. So this is ln of 4 plus 1 minus ln of 0 plus 1. And ln of 1 is 0, so this is 0. So we have ln of 5. If you put this in your calculator, you'll get about 1.6094. So that's the actual area between 0 to 4 of this function, and 1.62, this is the approximated area. So pretty good, not so bad.